Hello, I'm Ayush Kulkarni, and today we'll be learning about database management systems based on the third and the fourth lecture. So here we go. The topics that will be covered in this video are data abstractions, DBMS terminologies, DBMS architecture, system server architecture, classification of DBMS, and database design phases. So the first one is data abstraction. So there are three different levels of data abstraction. The first one is the physical level. It is the lowest level of data abstraction. It basically describes how the data is actually stored in the database, including the details of data storage and access paths. The characteristics are it describes the physical storage of data on hardware devices. It also includes the details of file structures, indexes, data compressions, and other hardware level data management techniques. It is managed by Database Administrator (DBA) to optimize performance and storage utilization. The second level is logical level. It is the middle level of abstraction that describes what data is stored in the database and the relationships among those data. It hides the complexity of physical storage and focuses on the data model. Its characteristics are it describes the logical structure of the database, including tables, attributes, data types, relationships, constraints, as well as the keys. It is managed by database designers and developers to define the schema and business rules. It provides a unified view of the data without regard to how it is physically stored. And the third level, which is the highest level of data abstraction, is the view level. It describes only a part of the entire database. This level is intended for end users and application programs to interact with the database. So it's basically for the consumer. Characteristics are it provides different views of the database tailored to the needs of various users and applications. It hides the complexity of logical and physical levels and presents a much more simplified and relevant portion of the database. It is managed by application developers as well as the end users who need specific data for queries and reports. The next upcoming thing is DBMS terminologies. So DBMS terminologies is again divided into three parts, which are one, data independence. Data independence is the capacity to change the schema at one level of the database system without changing the schema at the next higher level. So the types of data independence are logical data independence, which is the ability to change the conceptual schema without altering the external schema. And the second type is physical data independence. It is the ability to change the internal schema without affecting the conceptual schema. The second is instance. Instance is the actual data stored in the database at a particular moment. It is a specific state of the database at a specific point in time. And the third terminology is schema. Schema is the structure defined in a formal language supported by the database management system. It defines how data is organized and how the relations among them are associated. It has three types: external schema, conceptual schema, and internal schema. The next thing is data architecture. Data architecture is broken down into three main categories: first tier, second tier, and the third tier. So first tier is also known as the single tier architecture. It is also called a standalone architecture. This is the simplest form of a database architecture. Its characteristics are direct interaction between the user and the database, minimal latency as there is no network communication required. Third, it is best suited for development and testing environments because again there is no latency or lag. And fourth, it is not scalable and generally not used for production applications. The second is the second tier or the two-tier architecture. This architecture consists of a client as well as a server. The client directly communicates with the database server. Its characteristics are better performance than single tier as the client and server can be on different machines. Database security can be managed more effectively. It is commonly used in medium-sized applications. Scalability is limited, however, as the number of clients increases. So, so if you have more number of clients, it will create a load on the server and it will reduce the efficiency of the data transmission. The third is the third tier or the three-tier architecture. This architecture separates the user interface, the functional process logic, and the data storage into three different tiers. The first one is presentation tier, the second is application tier, and the third is the data tier. Its characteristics is that it is highly scalable, it is much more secure, it is much easier to manage, and changes in one tier do not directly affect the other tiers. So it promotes much more of a robust model compared to the other tiers. The next is classification of DBMS. So DBMS can be classified based on three different points, and those three can be further classified into many more. If the data is based on data model, it can be classified into relational or object oriented. If it is based on the number of users, it can again be classified into single user system and multi-user system. And if it is based on database distribution, it can be centralized. So basically, like one server has all the data, and the one server is providing data to all the other clients, or it can be distributed, which means it can have multiple servers who are linked to each other, all storing different things. And if a client wants to access a particular thing, it can just send a query and the servers will transmit the data. The next step is database design. So why is database design important? Again, if you want to keep the users, you need to create a database design that first has a much easier to use or like a user-friendly UI. And secondly, it should not be riddled with code so that it provides a challenge to the user to use. The second is phases of database design. So these are the six phases that the creators of any database use to sort of create a database. The first is the requirement collection and analysis. Second is conceptual database design. Third is the choice of a DBMS. Fourth is data modeling. Fifth is physical database design. And sixth is database system implementation and tuning. So that is it. Thank you so much.